You know, I forgot to take account of the fact. There we go. Okay, got to take account of the fact when you record, seems way back. Okay, anyhow, F of backward apostrophe A. Now I'm going to use my three numbers. Okay, so I'm going to use 3, 5, and 9 for A, B, and C. So F of backward apostrophe A, first thing I would do is replace that A with a 3. In many cases, you kept the A there, but then you substituted it in here. That's okay. But since you know what A is, it's safe to satisfy it. To satisfy it. Substitute it. Okay. Okay. F of 3 now. Well, what's F of 3? X has been replaced by 3. So we replace every X in the definition by 3. That's exactly what I told you last time, right? Okay, so that's a principle. It allows us to make sure the notation is correct, make sure we're writing things out correctly. And we're going to say, okay, if X is 3, X is squared, so that's 3 squared. And X is divided by 3, so that's 3 over 3. 3 squared is 9. 3 over 3 is 1. That gives us 10. Everybody understand that? I think you do. As I say, if you kept the A in there for a while, well, eventually you're going to have to put that 3 in for A, for the backward apostrophe A. Okay. Now F of backward apostrophe A minus backward apostrophe B. This gets a little into order of operations, but backward apostrophe A is 3. Backward apostrophe B is 5. So you get F of 3 minus 5. What's the next step? Well, the next step is you do what's in the parentheses. Now, there's a tendency for some people to say, well, that'd be F3 minus F of 5. That wouldn't work. That would give you something completely different than if you subtract the 5 from the 3. Now, that's because this thing has a nonlinear term, but I don't want to get into what that means. Okay, there are linear functions, like if f of x is mx plus b for any m and b, then you would actually have a distributive law, but you don't want to do that. Okay, anyway, and actually now I think about that, I'm not even sure what I said is true. F of -2 then, well, now we're down to just being able to substitute the number in. And we're going to, X has become -2, so we write -2 for every X. We square -2, we get 4, and then we get minus 2/3. Okay, and that can be written in many ways. I'll just write it as 3 1/3. Or 10/3, you want to put all this over common denominator 3. You could get 10/3. You could convert 3 1/3 to 10/3. Make sure you understand how to do fractions. Okay. Now, F of backward C over backward A, backward apostrophe C over backward apostrophe A is F of 9 over 3. Because in my case, C is 9 and A is 3. Okay, now if you got a question, you just raise your hand, I'll pause the video and we can talk, right? So, and if I'm not looking at your hand, throw something heavy at my head. Okay. It's got to be heavy or I won't notice. All right. Okay. You can always stop me if you have a question. Okay, so f of c over a is f of 9/3. And of course, 9 over 3 is 3. And coincidentally, we've already calculated f of 3. Okay. Don't write it out. And there it is. Okay. Now we get down here and we're not going to have numbers. I mean, there's a number here, there's a number here, and there's a number here, but we don't have numbers for D. So what's f of D? Well, D has replaced x, hasn't it? If D has replaced x, then we replace all the x's. So we write f of D equals d squared plus d over 3. And it kind of makes sense if f of x is x squared plus x over 3, then f of d would be d squared plus d over 3. F of aardvark would be aardvark squared plus aardvark over 3. Okay? Okay. Well, d squared plus d over 3 is okay. We can, well, no. I'm not going to simplify that at this point. That takes us away from our immediate goal, which is understanding functionalization. Okay. Now, well, what's f of d plus 2? Well, if f of x is x squared plus x over 3, f of d plus 2 is d plus 2 squared plus d plus 2 over 3. In other words, x has become d plus 2, so x becomes d plus 2 at every point. That did a good job of anticipating what my expressions are going to look like. I knew I was going to write an exponent, so I started writing d plus 2 up there with exponent. Okay, so first of all, there's f of d plus 2. Then we're going to do minus f of d. F of d is d squared plus d over 3. Now there's more we can do with this expression. But I'm just going to say equals, etc. We want to square the d plus 2, we want to expand that square and separate out some terms, and it gets a little complicated, and that's not what we're about right now. We're just about interpreting these expressions, okay? Now, f of d plus 2 minus f of d over 2. Well, f of d plus 2 is d plus 2 squared plus d plus 2 over 3. And then it's minus, and you want to be careful to put parentheses around the expression you get for f of d, because the whole f of d is being subtracted. There's a tendency, if you don't have the parentheses there, then the d squared would be minus, but without the parentheses, that minus wouldn't apply to the d over 3. So you got to be careful about parentheses and so forth. We'll have plenty of time to talk about these things. That equals something, and then it gets into some algebra. You're not going to be doing that much algebra right away. So there it is. Now, the thing I want to emphasize is just, you got a backward apostrophe A, backward apostrophe B, or backward apostrophe C. They stand for specific numbers. If you're a distant student, you can use these 3 numbers. A, B, C, 4, 7, 9. Okay. Okay, what I've asked everybody to do is copy a graph that looks something like this. I'm not sure that's even a function. Looks like it's going backwards there. It's going to fail the vertical line test. Don't worry about that later. Okay, so we have y equals backward apostrophe b on this line, and x equals backward apostrophe a on this line. Now, when you write it down, you can go ahead and write out your backward apostrophe b. But then I'm going to kind of lightly cross this out. I'm going to say, okay, in my case, that's y equals 5. And in this case, x equals 3. Okay. Now, make your own estimates for your numbers. What I want to estimate is for the x and y coordinates at this point and this point. What are the coordinates of this point and what are the coordinates of this point on your graph as you've sketched it? Okay, so it's not unanticipated. So you're having a little trouble making estimates because we haven't done this before. Okay. Now, which coordinate do we know for this point here? Don't say it. You see the point I'm pointing at? Higher point. Is that, do we know the x coordinate of that? Or do we know the y coordinate? Which one do we know? Okay, somebody thinks we know the x coordinate. Rest of you vote. Do we know the x coordinate at this point or the y coordinate? What do you say? And all you got to do is just make a little gesture so I know you want to say something. Okay, we've got to digress a little bit back to coordinate systems just to make it get you oriented. Just take a minute. Okay, here's where x equals 4, right? This point. The x coordinate is still 4, right? Because this thing's directly above x equals 4. So this is the line where x equals 4. Let's say this is a line where y equals 10. Now, 4 looks bigger than 10, but that happens all the time on graphs. If you're graphing the population of the world versus the year, you have years like 1950 and 1990 and 2020. But up here, you got populations like 3.6 billion, 4.8 billion, 7.7 billion. Okay, I don't know how close those are. Had the right order of magnitude. So you have billions up here, and you just have thousands down here. Okay, so you don't have to have the same scale for both axes. You have to have a consistent scale for this axis. So if this is 4, then if you cut that in half, it's 2. Halfway between 2 and 4 is 3. Halfway between 0 and 2 is 1. Okay, so we know that that's 1, 2, and 3, right? Okay, well, tell me, what are the coordinates of this? What's the x coordinate of this point? Show me some figures. Yeah, 4, right? What's the y coordinate? Yeah. If I had put 11 down there, you wouldn't have been able to tell me. There's 10, okay? So this is the point 410. Okay, so what do you estimate for the coordinates of this point? What's the x coordinate of this point? X equals 6 would be out here somewhere. Yeah. X coordinate's still 4. Okay, it's on the line where x equals 4. X equals 4 everywhere on this line, and y equals 10 everywhere on this line. Okay, so what do you think y is here? You're gonna have to go into double digits. Like if you think it's 38, you go, okay, that would be 38. Anybody think it's that big? Why is it 38? Well, because that's only 10, right? If you go another 10, you're going to be above that point, aren't you? So what do you think that's going to be? Do you think it's 12, which would be this? You think it's 19, which would be this? Well, okay. Okay, I got it. Okay. What do you think? What do the rest of you think? Okay. Well, that's the chunk that's bigger than 10, right? Okay, bring that chunk down here. It's not that much smaller than 10, is it? Or you think if I went to 20, 20 would be up about here. So we could actually make a line for y equals 20. It just equally spaced with this line, right? So we could say that, well, the y coordinate isn't quite 20, but it's certainly a lot bigger than 10, right? So I would say maybe 17. So I would say or 17, question mark. I think closer to 18, don't think it's 16. Okay. Now, what do you think the x and y coordinates at this point are? I'll turn this off now so we can talk. Now, I think everybody's got an estimate down there. To estimate the coordinates at this point, I'll just draw a vertical line through the point. Okay. So I can see where it hits the x-axis. And you can see the marks I've got here, maybe I'll make a little problem. That would be like x equals 1, x equals 2, and x equals 3. So it looks like on this line, x equals about 1.3. It's closer to 1 than it is to 2. There's still a little space there. Maybe it's closer to 1.2. And of course, if I do this from the point, I see that, well, that lies on the line y equals 10. So this point is 1.310. Make sense? Okay. Now let's just say before we return to the graph I had to sketch, that my graph did this. Okay. And this is a graph of y equals f of x. As I go from this point to this point, how much does x change? I'm going to write this down. Well, I'm going to write the question down, but we'll talk about it a little bit. But see if you can write out an expression that tells me how much x changes between those points. Some people have a little trouble processing this. Some people already obviously know the definition of rate of change because they've done it in their class or because they knew it already. Okay. The question is, what's the X value here? What's the X value here and how much does that change? Okay, so the question is, how much change is there? How much is X change between 1.3 and 1.310 and 417? X changes from 1.3 to 4, right? And you kind of want to identify that. It's pretty obvious. We're looking at the values of X. And how much does it change by? Well, I'm going to write delta X. How many of you are familiar with that delta symbol? Everybody seen it? It's like an upside down triangle. It's like the Greek D. You know, they made it more vertical, rounded it off. Became hard. Okay. So X changes by 4 minus 1.3, which is 2.7. Can you see that on the graph? Well, here's X equals 1.3. Here's X equals 4, right? If we go from this line to this line, this thing, this arrow, has a value that we say is 4 minus 1.3 equals 2.7. It's 2.7 units long and it points in the positive direction. Okay, there it is. And of course, we can say here, these lines are parallel, so the distance from here to here is the same as it is from here to here. So it's 2.7, right? Okay, well, now let's look at how much Y changes. Well, Y changes I really wanted to put the delta Y in there. So change of delta Y. Okay, so right here is a change of 7. I really want to write that on this side of the arrow, but I've got this. Okay. Now, the average rate of change of Y with respect to X is change in Y divided by change in X. Okay. In general, changing that over changing this. Now I haven't defined what I mean by this and that. Okay. But you can kind of think of it this way. That's the way it feels, changing that divided by the change in this. Okay. That is the value of y. This is the value of x. Okay. This is the independent variable, and the independent variable goes on the horizontal axis. Okay, so I write this out in a little more complete form. Where's my red chalk? As a rate of change takes up a lot of board space. I'm going to abbreviate it ROC. And WRT stands for with respect to. And it's change in y divided by change in x. That x looked awful lot like the y, didn't it? Okay. This is a big deal. You see examples in your book and in your homework. And I'll talk about more examples next time when I get the basics down. Okay, the other thing is, this straight line stays kind of close to the graph of f of x. But the graph of f of x isn't a straight line, so it deviates some. If I do it over a much bigger interval, it deviates even more. If I did it over 2 points very close together, the straight line would stay very, very close to the graph of a function. Okay. That's a very important concept. That concept leads us right into calculus. We're not going to go into calculus except in very little ways, not much further than I just did with that comment. That's a very important comment, worth understanding, worth trying to understand now so you're not stumbling over it when you take a calculus. All right. Well, I can depict this triangle here And I'll keep the colors the same. I'll just draw it a little bigger so I can label it the way I want to. And I can say this. Okay. And anticipate the more of the next thing. So, I have to write this next word pretty small. Got carried away, making the 2.7 larger than I should have. Okay. I say 2.7 is your change in X. That's your run. If you look at it geometrically. Okay. 7, well, that's your delta Y, which is right at this point, rise. Okay. Slope equals rise divided by run, which is 10 over 1.3. That's approximately 0.77. 7.7. Pretty close to 7.7. In the slope, represents the average rate of change. Because of course, if you calculated the average rate of change with delta X equals, oh, it's not 1.3, it's 2.7. And then this stuff is bad. Let's try to erase. Let's see if I can do it. How about that number 1.3? I guess I just really liked it. Okay, that's 2.7, and that's 8% less 4, which is about 3.7. And you can do my arithmetic for me if it's wrong. Okay. Just ballpark estimate in my head. Usually I'm fairly close. Sometimes I'm way off. Okay, the point is that we can represent the average rate of change between 2 points by this picture and by this triangle. Now we know how it's defined. And now I'm going to ask you to make estimates based on that graph you drew earlier. Try to estimate coordinates of the point that I asked you to estimate. Okay, I'm saying that people are having some trouble seeing the coordinates of these points because I don't have a grid. You know, in everything you've done, you've probably been given a grid. And all the points lie exactly on integer coordinates, and you haven't had to estimate anything. See, what it is, and the reason I want you to be able to estimate is you see things better once you're able to make estimates. Okay, so I would say in this case, from this point, I know that x is 3. So I can say this point is 3 something. Okay. Y is 5. So I can say that this point is something 5. And my graph is big enough that I can write that. Okay. Then I want to know what the x coordinate of this point is, because I don't know yet. And I want to know what the y coordinate of this point is. Now, as I showed you before, the easiest way to do that is go ahead and come down here. Okay, so if this is 3, then this looks like it's about a little more than halfway between 0 and 3, doesn't it? Halfway between 0 and 3 would be 1.5. Maybe it's 1.6. Maybe you just want to be lazy and use 1.5, and that's okay for estimate. It's not lazy. You're kind of in a hurry. You don't want to have to think that hard right now because you're concentrating on something else, right? So to concentrate on something else, it's fine. Go ahead. Put down 1.5 here because you're not going to try to send a rocket to Mars based on this estimate. Okay? You're not doing anything critical. The more critical it is, the closer you want to make your estimate. The more critical it is, and the closer you want to be able to do your analysis with algebra and all that stuff. Okay, over here we have 3. What's the y coordinate? Well, the y coordinate is here, okay? So I'm going to say this is the line x equals 1.5. It's not a bad thing to write this. This is the line y equals 1. This is 5. How big is this? Is it 10? No, it's less than 10 because 10 would be way up here. Okay, so I'm going to say y equals 7.5. Since I got a decimal here, that's okay. Okay, so put 7.5 here. Now I've got 2 points. I can calculate my average rate of change because everybody knows how to do that. Okay, that's hard. Making estimates is easy once you do it a few times. You're going to have to make estimates throughout the course. So go ahead and make sure you have sensible estimates on your points. And bring it in and show me next time. Just to, if there's something wrong there, we'll work it out.
Wait, can I go around?
Go ahead.
This way?
Yeah, you can't go in front of the camera. Even though you're not in this course. And of course, by talking, you've totally. If you were in class, we'd have had to trash the video. Okay. You probably weren't here when I said that because you were here in the second class.
Yeah.
Okay. Okay. Recording's on. Okay. Just forget and have it. Okay. That's not a problem.